Okay, we're on page 30. And we stopped at 87 here. Okay, so differentiable function f has the property that f prime is less than or equal to 3. So we know the slope is always less than or equal to 3 for values between 1 and 8, and f of 5 is equal to 6. Which of the following could be true? F of 2 is 0, f of 6 equals -2, f of 7 equals 13. So we can test all these order pairs and see where the slope falls under. Let's see, 5 or 6. Yeah, we just want to figure out which order pair. And then we're testing everything against f5 equals 6. So we're testing every point against that. And if anything is less than 3, we can keep it. If it's greater than 3, we know it's not going to match the option that we have. So between 5, 6, and 2, 0, we see a slope of 2. Between 5, 6, and 6, -2, we see a slope of -8. Between 5, 6, and 7, 13, we see a slope of 3.5, and that is the one that sticks out. It's not greater than, it's not less than or equal to 3. -8 is less than 3, so we keep that. We keep the 2. So answer choice C. Okay. All right, we see variations of this problem quite a bit. So I think on previous multiple choice questions, we've seen this comparing values between function derivative and second derivative. So let's build our relationship here. H is the area under the f graph. H prime is the order pair of f. H double prime is the slope of f. So h of 2 from 0 to 2, we can tell that this region is definitely giving us a positive value. So we know it's going to be probably the largest. H prime of 2 is f of 2. F of 2 is the order pair. Y value is 0. H double prime is f prime. F prime of 2. We see the slope of this graph is definitely negative. So largest, middle, least. Put it in the order from least to greatest. H double prime is least. H prime is the middle value, and largest is h of 2. Okay. 89, if we know the formula, then it's easy to set this up. Area is top minus bottom. With a calculator, the top graph is the sine x. The bottom graph is the e to the x minus 2. We just do top minus bottom from 0 to 1.0540. So yeah, we do have to set the equations equal to each other, find that intersection, which is 1.054, and then set that up as the upper bound.
So,
Mhm.
so if you what would you like figure out which one is the top and which is the bottom?
Right.
Like I know like sometimes I can figure out what the graphs look like just from like my memory. Like usually I'm like, I know what a sine graph looks like. But sometimes like, when there's like different
Yeah.
transformations, let me get confused.
Yeah, sometimes it's tough. I would say the easiest way to do it is figure out a point that you know that you're dealing with. Let's say x equals 1, and plug 1 into both functions and see which one has the higher value. Whichever is the higher value must be the top graph.
So that's okay, got it.
It's not foolproof, but at least it gives you some idea And if you get it wrong, you know your answer is still correct, it'll just give you a negative number in return. If you accidentally did bottom minus top, the numeric value will still be correct, it's just be negative instead of positive.
Okay, got it.
But yeah, but I like the idea, just plug in a number into each and see which one is higher, that'll be your top.
Okay.
All right, number 90, particle moves along a line, so that's velocity is given, so we have to enter that into our calculator. For what value is the speed increasing? So if we're thinking about a velocity graph, you know speed is increasing whenever velocity and acceleration have the same signs. So either velocity and acceleration are both positive, or velocity and acceleration are negative.
Go over like, just like, I'm just making a list of stuff to memorize, like, so like, what's like the rule for like, you know, if it's speed of the particle, or like, you know, how the average rate of change of the slope, or like, you know what I'm saying? Like,
Yeah,
like a quick, like, almost like key.
yeah, let me some of it I put onto the formula sheet, but I think I have other stuff kind of scattered around. But yeah, I can this is on the formula sheet here. Increasing speed occurs when velocity and acceleration have the same signs. Decreasing speed occurs.
Comparing velocity and acceleration.
That's right, yeah. But if you see the word increasing or decreasing velocity, then it's just acceleration. It's just the sign of acceleration. Yeah, so on the last 2 pages of your packet, I try to put all the most important formulas and ideas onto those pages, but you know, there's definitely stuff that that may have left off. But yeah, keep bringing those things up, and we'll see if they don't land on the formula sheet.
So so velocity is just acceleration?
So you see the word increasing velocity? Increasing velocity is simply talking about the rate of change of velocity, so it's just acceleration. So you see the word velocity, but it's that increasing is changing what it's talking about.
Okay, so rate of change of something is just what it's talking about, and speed,
Yeah, increasing, decreasing speed requires information for both velocity and acceleration. But if this rate of change of velocity, then it's talking about acceleration. Or increasing velocity is talking about the rate of change of velocity, which is acceleration. Yeah, typically the word increase and decrease changes whatever name of the expression is talking about. But speed is kind of different. It kind of has a special rule of having to compare signs between 2 different functions.
okay.
So if you're looking at the velocity graph, then you know acceleration is the slope of velocity. So we know that velocity and acceleration have the same signs if velocity is positive and acceleration is positive. So positive velocity means above the x-axis. Positive acceleration means positive slope on the velocity graph. So we see clearly an interval from 0.177 to 1.256, where the velocity is positive and the acceleration is also positive. Because acceleration is the slope of velocity.
Okay, and the velocity is, so basically, so when you're looking at the derivative graph, anytime that it's increasing and above the x-axis,
That's right.
that's gonna be both, okay,
That's gonna be both, yeah.
got it.
Or decreasing and below the x-axis.
Oh, okay, so, Okay, so when you're talking about speed increasing as long as they're the same side.
Same signs, yeah,
So you can't forget about the
negatives as well.
negative. Okay, got it.
So we have two intervals from 0.17 to 1.256. Where there's a matching relationship between velocity and acceleration. And then 2.057 to infinity, also matching. Negative slope matched with negative y values.
Okay. So for this piece, so how do you know when to put it into the calculator versus just trying to solve it by hand? Because I feel like my instinct is always to solve it by hand. And then it
Yeah,
gets stuck.
and I think that's a good instinct, but if especially if it's if it's calculator section, and you look at your equation, and it obviously looks a little too much to do by hand, right? Having to find the derivative for 2 to the negative t and finding critical points, you know, that's kind of out of the reach of our ability. I mean, we can do it with easier problems like polynomials, but anytime you have a weird exponential function, you know that your calculator, right, like this problem would, it wouldn't exist on the calculator section. It'll be too hard.
Okay.
Yeah. Okay, 91. Let f be a function defined for all real numbers such that f prime is greater than 0. So that means we want the slope to be positive. But then we also want the second derivative to be positive. So we want the rate of change to be continually increasing, but we also want the rate of the rate to be also increasing. So to find the rate, we can just do slope between the endpoints or slope between each of the order pairs. So this is what it looks like after I just spend time to find the slopes. So these are all changes in by ones. So I can just do -4 minus -3, which is -1. So I know this can't be it already. -1, -2, -3. I gotta have increasing slope. Increasing slope means it's got to move towards the positive direction. So already we know that f prime's out. Because it says that f prime is always positive, and we don't even see positive f primes. Here we do see positive f primes, right? Slope of 2, slope of 4, slope of 16. So we'll keep going, see what else we can gather. We get slope of 3, slope of 3, slope of 3. Now these are all positive slopes. That's great, but it's saying that the second derivative is positive. That means these slopes need to be increasing as well. And we don't see the slopes increasing, so it doesn't fulfill.
And bigger?
The number needs to get bigger, right?
So that would.
That wouldn't work. So part D, it does fulfill the condition of the slope being positive, right? 8's a positive slope, 6's a positive slope, 2's a positive slope, but the slope is not increasing, so D is out.
Okay, so I have another question. So if you want to get to concavity from just the way that we're getting the slope by hand, you would just take the slope of it again?
That's right. Yeah,
Like. Okay.
right. Because if you were looking at a graph, let's say you found the slope between these two endpoints, between these 2 points was -2, and then the slope between these 2 points was -1. You know that you're experiencing concave up because your slope is moving towards a positive direction. Right. So here you just see it from a table perspective, or what it would look like on the graph. So here, we don't even have to go any further than this. For part E, I already saw a negative slope here, so this is already out. I know this doesn't have a chance of being the correct answer. So my answer choice is going to be B, because B is that ability for the slope to be positive for every order pair, and then also a definite rise in slope. The rate of change. So 2 to 4 to 16, you see the slopes increasing. I think what I meant to say here was f prime greater than 0 means that the slope is positive. I mean, the graph is increasing, but slope is positive. Okay, 92. This is one of those derivative of inverse at a point. Go through your chart. Try to find g prime of 4. I know my order pair. The 4 must be the y value of my f graph. So my order pair must be f of -2 equals 4. If I can find f prime of -2, then that slope will lead me to the slope of g prime of 4. Okay, page 33. Okay, function satisfies the fact that the limit exists, which could be the following graph of f. So as long as the graph is headed towards the same y value, that's enough for the limit to exist. So all we need is, we need to pick 2 points on either side of 1 and see if the graph is headed towards y value 3. It doesn't have to reach 3, it just has to point towards 3. And we see option C is the best choice. Both sides are headed towards 3, even though the order pair lives elsewhere, the graph is moving towards y value 3 from both sides.
So. Limits were a long time ago. Why would any of these other answer choices be like? What's wrong with the other answer choices?
Because
Didn't you just draw the arrows like facing?
But you see how if I approach 1 from both sides, this side's approaching 2, this side's approaching 3. I need my limit to equal to 3. So that's my condition as well. I need the limit to be 3. So here, if I pick points on both sides,
3's wait.
3's the y
Three's the
value.
Y value.
Yeah, 3's the y value I'm targeting now. So your limit is always referring to something about the y value.
for that problem, it just says equal to, you're just assuming that that's the Y value.
Yeah, so if it's f of 3, then it's simply the order pair. But if it's limit, it's got to be it's got to be heading towards that value. So here f of 3 is simply that island point by itself, which is 4. Not the right answer. If we're approaching 3 from the left side of 3, that arrow's headed towards a Y value of 2. It looks like the right answer. Let's just test the other ones. Approaching 3 from the other side of 3. It's headed towards 6. And then the limit, the full limit doesn't even exist because the arrows are not in agreement. Number 3, you can just step through continuity conditions. Your order pair. Oh, sorry. Yeah. Order pair, f of 2 equals 7. Second condition, does the limit exist? The limit is going to talk about the graph. The graph is referring to the first piecewise, because the second one is just a point. So okay, if you try to evaluate it, you'll get 0 over 0, which you can do L'Hopital's rule, or you can factor. Either way, you'll get the same answer. You'll get 5. So this tells us that the order pair is at 2, 7, but the limit is at 5. So the graph may look something like this. Obviously, limit exists, but not continuous, because this hole is not getting filled in by that order pair. So removable discontinuity.
Jump discount.
Yeah, jump discontinuity typically happens if you have a greater than and less than. Like for instance, if I had this function here. If you try to find a limit, the one side limit is not going to be in agreement. If I plug 1 in here, I'll get 4. If I plug 1 here, I'll get 6. If I see that there's a disconnect, my limit can't even stand to be true, this is going to be a non-removable discontinuity. It's where your one-sided limits are not in agreement.
That's jump.
That's a jump, yep. Jump is,
Okay, so jump is where like the limits don't even meet.
don't even meet, yep. The
Got it.
graphs don't even meet.
Once they meet. there's a. Okay,
Right, the limit exists, but the point lives
got
elsewhere.
it.
Okay, let f be the function defined above. For what value of b is the function continuous? So we want to force continuity, but these b values is kind of forcing these functions to kind of be, they're kind of floating. It's not set. So we want to force these to set in a way where they're not only going to meet, oh, sorry, that they're going to meet at 2.
And then hold that two.
Yeah, so I just like to go through my continuity conditions and just step through and make sure that every piece is true. F of 2, that's talking about the first piecewise. So e to the 2b. Where b is just some unknown number that eventually we're going to solve. Limit. We have split functions here, so we're going to do approaching 2 from the left and also approaching 2 from the right.
That because the twos are, like they go around each other because it's the.
Yeah.
Greater than.
That's right, because that's where the potential break could occur. So if we want this limit to exist, we need the e to the bx equal to 1.52 plus b. Right, these have to be in agreement. I'm sorry, the 2 goes in for x, not the b. So e to the 2b. Now, where is e to the 2b equal to 3 plus b? How can we solve for this? This is meant to be a calculator question. So I like to bring everything over to one side and graph it. Look for the x-intercept. I always do x-intercept if I realize the equation is hard to solve by hand. Solving for b is same thing as bringing everything over to one side, graphing this, and looking for the x-intercept. That's the same thing as solving, if I could solve this out by hand. Because I really, unless I do guess and check, right, it's hard for me to solve for b if I have, when is e to the 2x equal to 3 plus x? That I don't really know. But if I can create an equation where, now you could also do this, you could also graph these two functions and look where they intersect. But typically I don't like to do that because sometimes I may have to be searching all over my window to figure out where the two intersect. Rather, if I just bring everything
So
over to
when
one
you bring
side.
it over, you're just shifting it down to the x intercept.
Right. And I'm just basically looking for the solution. I'm just making it easy because I'm always looking along the x-axis rather than all over.
Okay. So. I'm seeing my 2 points, are those just gonna be my answers?
Yeah, negative 2.9 and 0.6. And then those are your answer choices, part D. Okay, a lot of limit problems here to begin with. It's easiest if we can just sketch a graph that resembles that situation that they're talking about. So I just drew a hypothetical graph. Just so I can have something to work off of when I read my choices.
Okay. Would the correct answer be A?
You want the one that must be false. So it could be at 0, but it doesn't have to be. I mean, the way I drew it, it didn't
It just has to be
less than 5, so it's a possibility. So we can't rule that out to be always false.
We can't. Okay, so the only one that we can. Well. Okay, it's D because it's not continuous, that's 6.
Right. Because the limit has to meet at the same place in the order pair. If it doesn't, then there's no way it can be continuous.
Okay, I think what was throwing me off was that the graph was continuous for both sides, but not at the actual.
Right, right. Which means that the limit does exist,
Right, but it's.
but it's not continuous, right?
At 6.
Mm-hmm.
It would be just the removable,
It'll be, yes, right. That's right. Discontinuity, right?
which is just so fun.
Okay, number 6, more continuity conditions. You're welcome to use L'Hopital's rule, which gets you over 0, but you can also factor.
Yeah, okay, so you would take the left side and the right side?
The limit of the top one.
Why wouldn't you take it on the left and the right side? Cause we know it can't. Well, what,
Because the left and the right are both talking about the same function. So there's no need to do one side limit, because if we're talking about the same function, we're gonna get the same result. The only time you gotta worry about a left and right is if your inequality shows greater than and less than. If it's that, then there's distinct 2 functions on either side.
but don't we know that it can't be 3?
It also means everywhere except at -3. That means this graph is to the left of -3, and it's also to the right of -3. Oh, that's right, from downstairs. Thank you. Appreciate it. Yeah, in order for my first two conditions to agree, that K must be equal to -3 halves.
Oh, would you not just set the denominator equal to 0? To find the vertical,
Yep,
that's it.
but we have to test using decimals to see which direction it's headed. Is it going to positive or going to -infinity? But I'll do the easy ones first. I'll do the horizontal asymptote.
So how do you find a horizontal asymptote?
You do limit as x approaches infinity. And just compare the degrees.
So, okay, to be clear, vertical asymptote is just setting the denominator equal to 0. Horizontal asymptote is setting,
Is evaluating the limit as x approaches infinity.
what does that look like visually?
Remember how we have a different set of rules for infinity? We compare degrees. If degrees are the same, we take the ratio of the coefficients. Because the highest degree is x to the first power. So 2/1 is 2.
Okay.
If we go to
Like,
what does that look like?
well, like the asymptote on the graph with like the limit and stuff.
Yeah, so that's the last part here. So if I do limit as x approaches -1 from the right side of 1. So if I just treat this like a problem that we saw from chapter 1, first thing we do is plug in -1. We get -2 plus 3, which is 1. -1 plus 1 is 0. So this tells us that the limit doesn't exist. But it's a one-sided limit. So we know that, okay, it's not asking about the full limit. It's just asking, is the graph headed up or is it headed down? But we're doing this without a calculator. So the way we do this is we use decimals. So we pick a value to the left, sorry, to the right of -1. So here's 0, here's -1. We choose a value to the left, sorry, to the right of -1. So we choose -0.9. Okay. So 2 times -0.9 plus 3 over -0.9 plus 1. Now, -0.1 is close enough to -1, so 2 times -1 is -2. -2 plus 3 is gonna be positive. -0.9 plus 1 is also positive. Positive or positive is positive, so you know that this graph, if you were to graph it out, it would have this behavior, it would be going up. And that matches the answer choice C as well, so all three are true.
Like, this isn't a horizontal, oh, gosh. Okay. I'm not gonna lie, I'm like really tired, and I think I'm just gonna call it, because
Okay.
thinking, right? But thank you.
Mm-hmm. Yeah, we'll pick up tomorrow.
Yeah.
I know, a few more days. Power through.